Hello, hope this video finds you well. We're going to take a look at this Waterloo CCC problem from 2013. It's actually one of my favorite problems when I'm first meeting students and they say they have a little programming experience and I say try this one because it has a couple it tests a whole bunch of different things and there's a really interesting and fun way to do it. So it's called rotating letters. And so essentially the problem is an artist wants to construct a sign whose letters will rotate freely in the breeze. In order to do this, she must only use letters that are not changed by the rotation of 180 degrees. And they list the letters there. Write a program that reads a word and determines whether the word can be used on the sign. And now we have the input specifications. So it says the input will consist of one word, all in uppercase with no spaces. The maximum length of the word will be 30 letters, and the word will have at least one letter in it. And so inside this statement, you really want to take note of the post or the preconditions of the input. So it's all uppercase letters, there's no spaces, and it has a length restriction. The output specification is either output yes if the input word can be used in the sign, otherwise no. And they give the example shins, and the output is yes because the letters in here only consist of those letters there. Versus noise, the answer is no because we notice that the E is not a rotating letter possibility in this case. All right, so what are we going to do here? Well, step one is we take our input, and in my case, I always like to do this when I'm setting this up. So word is equal to, and I'm just going to put the word in. I like doing this because it's faster when I'm testing. And then just before I upload it to the online marker, I'll actually change it to take the input manually. Okay, so step two. Now there's a couple ways to go about this, but with this problem in particular, it's really useful to actually define this as a function. And the reason why it's really useful to define this as a function is because the approach I'm going to take is I'm going to loop through word, and if any of the letters are not one of the valid letters, I'm going to stop right away and return no. And so by doing that, it's useful to be in a function because I can just stop the function at any point. So step two, we're going to loop through and check each letter. So I'm going to write my standard loop for I in range, and we're going to say 0 to the length of words or word, and we're going to increment by 1. And I'm going to say if word at I, so I'm going to pull out the individual letter. So if word at I is not equal to, and then what are my letters here that I have to account for? I, O, S. So if words at I is not equal to I, and we're just going to take this and copy this a bunch of times. Words at I is not equal to O, and words at I is not equal to S. And this is going to be long. Words that I is not equal to H. And words that I is not equal to Z. And words that I is not equal to X. And words at I is not equal to N. And so what I've essentially done is I've said, when you check each letter, I know this is a long one, so as I check each letter, if it's not an I, not an O, not an S, not an H, so again, all are possible letters. Let's make sure that's an O, not a 0. So I, O, S, H, Z, X, N, I, O, S, H, Z, X, N, perfect. Well, if that's the case, I don't have to check any more letters. I can just return no straight up. If I make it through the entire loop, I'm going to return yes. And this is why putting it in a function is so useful, because by putting it inside of a function, I can just stop as soon as I invalidate. So if I come in here and I'm going to say problem, I'm just going to invoke the function. And let's come in here. Let's go into the function. There it is. So I'm going to say Python 3, and I'm going to run this. What happened? Oh, I said if. That should be for I in range. Pardon me. So if I now run this, oh, a lot of little errors here. Words, that should be word. Third time a charm? Let's find out. So you'll notice it ran, but nothing happened because I actually have to print out the value. So I'm going to actually say print, and I'm going to invoke problem. There we go. So basically I invoke the function, so it runs it, and whatever it returns is going to print it out. So if we come back here and run it, I get yes, and that's right, because shins makes it through and it never enters this if statement. But if we look at the second example, noise, and so now I'm going to say here, I'm going to go noise and save it. When I run it, I get no. There we go. So now that I'm ready to submit this to the contest, what I would do now is I would just say input, and that's it. So now when I run this, I save this, I run it, and the input is shins, yes. I run it, noise, no. I run it. If I put, say, X, X, H, and S, yes, because those are all valid. If I run it again and I say X, H, N, A, no, because that A. If I run it again and I try just a whole bunch of A's, no. We see it works. So this is a way you can do this problem. And it's actually a way that I really encourage students to do the problem because it kind of highlights the standard structure of a loop to go through every character of a string with a single if statement inside of it. Very nice approach. But here's a really fun way to do it. So I'm going to make a new function called problem alternate. So this is just another approach, and it's going to leverage this replace, which I really like. So I'm just going to invoke alt, and I'm just going to do something here. So I'm going to take word, and I'm going to set word equal to shins. I think in the question it said shins. There we go. So watch when I do this. When I say word equals word dot replace, and I'm going to use this replace function, which is a beautiful function, and I'm going to say replace all the s's with an empty string. And watch what happens here when I print this out. So if I come here and run this, oh, I should return my word. There we go. Let's return the word, right? Because so basically I'm going to invoke problem alt. I set word to shins. I replace all of the s's with an empty string, and then I return it. And when I do this, notice how the s's disappear. So what's really nice about this is I can take this and I'm going to replace every one of those letters with an empty string. So we have S. So what's our letters? We have I. We're going to replace all the I's with an empty string. We're going to replace all the O's with an empty string. We're going to replace all the S's with an empty string. How many more are there? I, O, S, H, Z, X, N. So we replace all the H's with an empty string, replace all the Z's with an empty string, all the X's with an empty string, and all the N's with an empty string. Let me just give some space here so you can see what's going on here. There we go. So I, O, S, H, Z, X, N. So this nice approach where we're taking advantage of this, what I call collapsing a string. Collapsing a string is when you replace a specific substring with an empty string, and that string will shrink, which is really nice. And here's the thing. If we replace all of those special characters with an empty string, the result is that if this only consists of these strings, the string's going to be empty. So I'm going to say if the length of word now is equivalent to 0. So basically, when I replace every one of those letters with an empty string, if there's nothing left, that means it only contains these characters. So I'm going to return, in that case, yes. Otherwise, I'm going to return no. And so now when I save this, and I come back and run it, I get yes for shins. I can change this to noise, and I should get no. And there we go. So again, now that I'm done this, I'm going to set this and take my input. So two different approaches to the same problem. So this approach is, maybe not necessary, but it highlights this really nice idea of using a for loop with a single if statement inside of it, which is a really important structure to understand as a beginning programmer. And this one just has this nice technique where you can collapse a string by replacing a character with an empty string. It's a really powerful technique, really useful in a lot of cases. And also, this problem was the type of problem where if the minute I find a character that doesn't belong, I can stop. And so that's why putting the solution inside a function is really useful, because as soon as I find a character that doesn't belong, I return no, and the problem stops running. So I hope this helped. If you have any problems, please don't hesitate to reach out, and have a great day.